So welcome everyone. Today we'll continue with limits, and we are going to start with the limits of the radical function here. When I say radical function, that is the function involving the radical sign or the square root sign or cube root sign, like that. So here we are talking about the limits involving radical functions. I can say limit involving radicals. So in these two examples, you can see we have the limits and there are radicals involved. There's a square root there. Here also we have the square root. So how we can find the limit of the radical functions? We are going to explore that in this example. We are going to begin with first example, that is part A here. So when you look at part A, we have limit as x approaches to a of the square root of 3x plus 1 minus the square root of 3a plus 1 over x minus a. So first step in finding the limit is to perform the direct substitution. So if you try direct substitution here, we have x approaches to a. So if you plug in a for x, for example, here in the denominator, it will be a minus a. A minus a will be 0. 0 in the denominator. For a fraction, you cannot have 0 in the denominator. So we cannot compute this limit by direct substitution. So what we are going to do is we are going to use a technique called rationalization. While using the rationalization, we'll be using this factoring formula again. Let's write that formula. Factoring formula. Our factoring formula was a squared minus b squared is equal to a plus b times a minus b. We'll be using that formula in order to solve this first example. So if you factor a squared minus b squared, you will get a plus b times a minus b. Or you can say if you multiply a plus b and a minus b, your result will be a squared minus b squared. So you can use this formula in both directions. If you do it in forward direction, you are factoring. If you use that in backward direction, you are multiplying. So using the formula in forward direction is for factoring. Using the formula in backward direction is for multiplication. So what do we do? Because by plugging in x equal to a, this will be undefined, denominator will be 0. So we are going to rationalize. So we multiply both numerator and denominator by the conjugate of the radical. Here the radical is square root of 3x plus 1, then minus square root of 3a plus 1. So when I say conjugate, the sign in the middle will change. So we are multiplying by 3x plus 1, then plus 3a plus 1. You have to multiply both numerator and denominator by that. Square root of 3x plus 1, then plus square root of 3a plus 1. So what I have done is I multiplied both numerator and denominator by the conjugate of this radical here. Here is the radical with the square root. When I say conjugate, I have to multiply by changing the sign in the middle, so plus. And when you multiply both numerator and denominator by same quantity, it is same as multiplying by 1. And by multiplying by 1, the value does not change. So that is the first step. And this step is called the rationalization. Meaning of that is this irrational radical in few steps after this will be rational. And also this factor in the denominator x minus a, which was causing 0 in the denominator, that will get cancelled. Now let's simplify this one. So we have limit as x approaches to a. Now what we have is we have two fractions here. This is the first fraction, numerator over denominator. Here is the second fraction, numerator over denominator. We are multiplying the fraction. And you know that when you multiply two fractions, we multiply numerator with numerator and denominator with denominator. So if I multiply the denominator, we have x minus a multiplied to that quantity. So when I multiply the denominator, I have x minus a multiplied to the square root of 3x plus 1 plus the square root of 3a plus 1. That is what I have in the denominator. Denominator, when you multiply, we multiply the denominator with denominator. So it is x minus a multiplied to this. But if you look at the numerator, it's quite interesting here. It is like square root of 3x plus 1 minus that, and the square root of 3x plus 1 plus that quantity. So it is just like a plus b multiplied to a minus b. The first two quantities are same, like a and a. One is minus, other is plus, like this one, plus and minus. And the second quantity is b, or here it is square root of 3a plus 1, square root of 3a plus 1. So this is just like a plus b times a minus b. So what we know is if we multiply these two, it will be a squared minus b squared. That is the square of the first minus the square root of the second. So if I square the first one, square root of 3x plus 1. If I square this, it will be 3x plus 1. 3x plus 1. Then minus a squared minus b squared. When I square the second one, it will be 3a plus 1. So we multiplied the numerator. So to multiply the fractions, we multiply numerator with numerator. We got that. We multiply denominator with denominator. This is what we have. Now we are going to simplify the numerator. If we look at the numerator carefully, we have 3x plus 1. Then if we simplify this, it will be minus 3a. And if I distribute the negative sign, that will be minus 1. So it will be 3x plus 1. Let me write that. Limit as x approaches to a, 3x plus 1 minus 3a minus 1. Denominator, I'm going to keep it like that. X minus a times the square root of 3x plus 1 plus the square root of 3a plus 1. And 1 in the numerator get cancelled because one is positive, the other one is negative. Now, let's see, we get limit as x approaches to a. Now in the numerator, you have 3x minus 3a. So when you have 3x minus 3a, 3 is a common factor. If you factor that 3 out, you get x minus a in the numerator divided by 3, divided by in the denominator, we have x minus a multiplied to the square root of 3x plus 1 plus square root of 3a plus 1. So when you come to this step, you can see that in numerator you have x minus a, in the denominator you have x minus a. So you can cancel this. This x minus a was causing the problem in the beginning. Because we have x minus a in the denominator, when you plug in x equal to a, it used to be a minus a, which was 0. So we cannot have 0 in the denominator. We did all this process and we removed the denominator. Now the direct substitution will work. Now we can perform direct substitution. So in place of x, we are going to plug in a. So in the numerator, you have a 3. So 3 as it is in the numerator, divided by, in the denominator, this is already cancelled. We have square root of 3 times, in place of x, we are plugging in a. So 3 times a plus 1 plus, in the second radical sign, there is nothing to plug in. It is just the square root of 3a plus 1. Square root of 3a plus 1. So now we can simplify this. In the numerator, I have 3. In the denominator, we have square root of 3a plus 1 plus square root of 3a plus 1. We have 2 of them. So I can write that as 2 times square root of 3a plus 1. So that is my final answer. That is the limit. That is the limit of this function involving radical. So because we have a function involving radical, when we try direct substitution, denominator was becoming 0. So we perform rationalization. By performing this rationalization, we were able to cancel the denominator. So no more 0 in the denominator as we had here. And we can perform the direct substitution to get the result. So that is the end of the first part. So now we are going to work on part B. I'm going to write from the top here. So in part B, we have limit as y approaches to 0 of b minus the square root of b squared minus y squared over y squared. So here also you can see this limit involves a radical there. We have a square root of b squared minus y squared. First step, we'll try to do the direct substitution. If you plug in y equal to 0, if you try to plug in y equal to 0, you can see that the denominator will be 0. You cannot have 0 in the denominator. So what you'll do is you are going to rationalize by multiplying both numerator and denominator by the conjugate of this radical. So we are going to multiply by, here we have b minus, so we'll do b plus the square root of b squared minus y squared over b plus square root of b squared minus y squared. So that is the first step. You have to rationalize the radical. Then after you rationalize the radical, what will happen is after you rationalize and then simplify, this y squared, which is making 0 in the denominator, that should get cancelled. So let's go to next step here. You have limit as y approaches to 0. Now you are multiplying two fractions here. You will multiply numerator with numerator and denominator with denominator. So this is like b minus that quantity, and here we have b plus that quantity. So it's like a minus b times a plus b. When you multiply, the result is a squared minus b squared. So the square of the first one, which is b squared minus the square of the second. When you square the second one, this square root will vanish. You'll get b squared minus y squared. And in the denominator, you are multiplying y squared with that quantity. So y squared times b plus the square root of b squared minus y squared. Next step, let's see what we get. Limit as y approaches to 0. You have b squared minus b squared. If you distribute this negative sign, minus b squared, now negative and negative, positive y squared. Positive y squared. In the denominator, you have y times y squared times b plus the square root of b squared minus y squared. Now in the numerator, if you look at it, there is a negative b squared, there is a positive b squared. So those two get cancelled here. And the remaining thing is the limit as y approaches to 0. In the numerator, you have a y squared divided by, in the denominator, y squared times b plus the square root of b squared minus y squared. So now you can clearly see here this y squared get cancelled because you have y squared in the numerator, y squared in the denominator. There is no plus or minus sign, so you can cancel. So y squared divided by y squared, that is 1. So y squared over y squared, that's 1. So what we get is, in next step, if we rewrite this, this is same as limit as y approaches to 0. You have 1 in the numerator, and in the denominator you have b plus the square root of b squared minus y squared. So that's what we have in the denominator. So now you can see that factor, which was y squared, that causes 0 in the denominator, is no more there. So now you can perform direct substitution. So this is equal to, if you perform direct substitution, what you're doing is you're plugging in 0 for y. So it will be 1 over b plus square root of b squared, because this y squared, 0 squared is 0. So b squared minus 0 is simply b squared, which is equal to 1 over b plus square root of b squared is b. That is 1 over b plus b is equal to 2b. So that is the result for the second part. Part B, the limit is equal to 1 over 2b.